Flowchart apa semua. Buat diagram.
Tapi bukan nak dalam masa seminit ke? Kan macam nanti lama lah pula kalau tunjuk.
It's okay. Just present. Can anything that requested by your assessor, just present. Okay. All right. Anyway, don't forget to press the recording button. All right. Anis, Nadia.
Okay, sir.
Okay, Syazwan, semua dalam semua best student ada dalam ni. All right. Don't forget to press the recording button, and then anything requested by the assessor, present lah. Kan dia minta tu buka slide tu slide, just present, just cooperate. Okay. Alright. Okay, thank you very much. Alright. Assalamualaikum. Welcome. Okay.
Ramai orang kan.
Panas tu. Okay, got my coffee, Alhamdulillah. Bismillahirrahmanirrahim. That really good. Okay. All right. Test name.
Yes, sir.
Okay, please.
So we so we just go through the methodology, or do you want the whole explanation? Methodology.
Yes.
Okay, I'll share the
Yes, you share your stuff. Your
slide.
Your
Wait, can you see it or not?
Yes, I can see it.
Okay. Jap, where's the methodology? Okay. Here, so Assalamualaikum and good day to Dr. Sabri.
Salam.
I am Warnita binti Fazri Zaidi with the project title Development of B2 Poster, and I'm the supervisor under Madam Azina Kamaru Bahrain. So we go through the methodology for this project. It It consists of 6 parts. Start with the technical hardware. For technical hardware, it involves 3 components, which is Node MCU, flight sensor, and vibration motor. Node MCU acts as controller targeted for IoT-based application as it runs ESP8266 Wi-Fi. By using this Node MCU, it makes the device more convenient and versatile. And as for the flight sensor, it sends any slouches occurs on the neck where the resistance will change and the corresponding change in the output will occur. For vibration motor, it will excite to remind whenever the user exceeding the tiltation limit.
Okay.
Second is the technical software. For technical software, this project used Arduino IDE to sketch the data to the Node MCU, and Blink apps was used because it's compatible with every device, either iOS or Android software system. So we go on with the block diagram. In this project, the input for B2 posture is the flight sensor, where when it senses the angle of the user's movement, then the user will make interfacing through the smartphone as it connected to the wireless communication module, which is not MCU. And as the sensor detects, it will display the reading of the angle of the user as the sensor detects, it will display the reading of the angle in through the user's smartphone, and if there any detection limit exceed, the vibration motor will trigger. Okay, here is the sequence of movement for B2 posture. To indicate the beginning of the program flow, user need to attach the device on their neck. Then the flight sensor detect movement with the presence of pressure. Thus, all the input data in software used will be sent to the controller. If user reach less than 15 degrees and stayed about 20 seconds, it will passes the vibration motor that gives tingling sensation to give command or reminder for the user. Then the vibration the vibration still give the comfortable effect for the user. If user does not exceed the detection limit, it will stay at the start of the program. Why the detection limit is less than 15 degrees? In a study, head and neck posture at computer workstation, what's natural stated, head tilt posture in their study range about 10 degree to 15 degree of extension. While user doing their jobs, they can see the reading of their angle on the smartphone apps to keep track with their posture. Therefore, this flowchart indicates the end for the device program flow. Here is the wiring schematic. This is not MCU with the vibration motor and the flight sensor attached. And the schematic diagram for this project. This is the result for B2 poster. As can be seen on the screen, this is how it's displayed on the smartphone apps by Blink. It has the date and time along with the exercise reminder that we have two options, either 15 minutes or 30 minutes break. So user can choose either one. This process used Cloud Blink using the Wi-Fi, which gives the exact time so that it will not confusing the user. The flex angle button is used to help trigger the function of motor and buzzer. Here is the conversion table between angle of flexion and resistance, because this result is to prove it when the flat sensor is bent, the terminal resistance as well increase. And the voltage divider formula is for convenience the resistance parameter to voltage parameter. So with increasing band in flight sensor, the voltage output indicates the voltage drop. So as for the result of my project, I think it's for me it's working and achieve all the objective,
Mm-hmm.
and which for my objective, here is my objective. It does all of this, and I think that's all. I believe that's all
Okay.
from me.
Thank you very much. Okay, explain me what is a B2. So could you define them?
Okay, B2 posture. B2 is a combination of words that start with 2B, which is oh, which brilliant brace. The brilliant is based on the technology applied, and brace is to give support or forms of support to our body, especially the neck area.
Brilliant, you said.
Yeah, I think it's brilliant.
Another B what?
Brace, BRACE.
Brace.
Yeah.
Brilliant brace posture. Okay. Could you explain me what do you know on scoliosis?
Scoliosis. I think my project is more to neck area. So yeah.
So what is the best brace for scoliosis? What the best design?
Best design?
Yes.
You mean the angle? Or
Depends. Because you written into your introduction, don't you? You say your design that fits to the sum of problem with scoliosis, back pain. So we want to know what is.
but my limitation for this project is only for the neck area, which is the tight neck syndrome.
Yeah, I know that limitation for
Yeah.
you, but as you mentioned in your introduction, you have to cover for that because you are in medical electronic program or medical stuff. Then you written as scoliosis. So that people I think interested to know that further. So I need to know that further. What kind of that? So what that design can solve that problem. Then I can see your project really useful.
Wait, let me think first.
Now you don't have much time to think because you got only.
Because closure of the spine. You mean the design is my project? Is it applicable on this scoliosis or how?
Yes, probably.
Because scoliosis is the abnormal curvature of the spine, and so I'm sorry, but I'm not sure about this because to be honest, I only study about the neck
So you
area.
can answer the question. There you go. Number 2, from what you can analyze B2 posture from your work.
What I can analyze is it helps people to get a good position, get a good appearances and
No.
position.
No, I mean your data. So how are you going to use the data that really useful for the user? That means analyze. But you did your projects and then you got a certain data with you, don't you?
Yeah.
Okay. And the data law of number, and probably it come up with this graph. Did you got a graph? Show it to me. Okay, for example, graph number, I saw one of graph. Where is it?
Graph.
No graph?
No, I think
Oh,
there's
very
no
bad.
graph.
Hmm.
No graph,
No
only
graph.
table.
Only data. Only 1, 2, 3, 4, 5, 6, 7 data. Conversion table between angle of flexion, and resistance.
Yeah.
Hmm. Anything
So,
else? Any question from you?
no, there's no question for me.
Okay, thank you very much. That's name.
Okay, thank
Okay.
you.
Time off.
Oh,
Okay.
I
Assalamualaikum.
see. Salam. Thank you, Doctor.
So I hit the leave button. I'm supposed not to do that, isn't it? So who's next? Max. Nadia.
Lama.
Hmm?
Yes,
Alamak.
it's with.
Hmm?
No, it's hang my laptop just now.
So are you ready?
Okay. And I'm sharing. Wait.
Anis Nadia, I will find your slide first. Nadia. Anis Nadia, okay.
You see my slide?
No, not yet. Wait. Okay, proceed.
Hello?
Yes, I can see.
Okay.
Carry on.
Oh my god.
2 minutes.
I think it's my internet line. It's hanging. Okay. Assalamualaikum and very good morning to my respective assessor, Dr. Sabri. So, I would like to present my first methodology, which is my flowchart. So, first of all, it is from start button. By pushing the start button, then the range sensor will detect the wheelchair. If the range sensor is more than 25 centimeter, the trolley will move forward follow the wheelchair person. And if the range sensor less than 18 centimeter, the trolley will move backward follow the wheelchair. If the sensor not detect, so the trolley will stop and it turns back to the range sensor need to detect the wheelchair. If the left IR sensor not detect the wheelchair, the trolley will turn to the right. If right IR sensor not detect the wheelchair, the trolley will turn to the left. Will sound up, the range sensor need to detect the wheelchair. But if both sensor detect the wheelchair in good condition and it detect the wheelchair, so that is the process. So next is my block diagram. There are 12 sensor use the right and left position. There's a pair of ultrasonic sensor used in the middle. Output, then it will microcontroller, which is Arduino, which it gains power supply from 12 volts battery. Then it will goes to the motor driver, which it will drive the DC motor right and also DC motor left. So here on the first image is picture of also a picture of switch This is important because speed and torque is important because it is important part in selecting and operating of the DC motor. When the higher the load, the higher the torque, so the speed will become decreased. Here present
Anis, where you are? Anis? Currently, where you are? Okay. Can't hear you well. Are you presenting from home? Present from home.
Hello.
Yes, yes, yes. Finish?
Hello.
Hello, yes. Can you hear me? Are you at home or at hostel, BMI? Can you hear me? Can you hear me?
Hello, sir.
Yes, yes. Yes, yes.
So I'm not sure my line over here stuck or what.
Okay. Could I
Where
start with the Q&A?
Oh, okay, okay.
Okay. So basically, your design is to monitor could you do private chat to me? Could you do your mobile number? I'm going to make a call. Are you okay with that? Easy. Where to find private chat here? I don't know.
Sir,
Yes.
I'm using phone because I don't know my laptop connection with the Wi-Fi. I'm not sure. So right now I'm using my phone. So
Yeah,
now I
I
can
think it's
hear you.
very bad Wi-Fi. I don't want to make it very worse.
Okay.
Could you? I think there will be a second effort. So could you? I think it's a good if I call you and then you just straight away answer my question. Is it fine?
Okay.
So how to get your number?
You want me to press 0? You want to call me right now or how?
Okay, I call you right now. 01
011
1.
2702
Okay.
8676.
76. I think using mobile much more easier. Okay, hello. You can disconnect the Teams. All right. Just a quick reply my answer. Okay. So this project actually to monitoring the big rim. Autonomous again trolley. Okay. Trolley. You know, Hanis Adriana. So I'm following the wrong person. Anis Nadia, Allahu Akbar. Okay, give me a second. Trolley padan. Probably. I couldn't find anything. Like resubmit. By the way, do you have do you submit into Teams file on this slide presentation? Okay, couldn't find this one as well. Or probably you can do it later. You do it later. Okay, all right, just brief. Is it working? So who's your supervisor? Mr. Zubir? Okay. All right, so the idea to ask a trolley follow the wheelchair. So this project applicable in more where this project can be applied to in supermarket, in What happened if the trolley stuck? Like I always found the trolley stuck without any connection between wheelchair or not wheelchair. Okay. All right. So then the prototype has been successful. Okay, I will do it. Okay, so how did you analyze this project? Eight kilo. By the way, Anis. Okay, you mean 8 kilo by the trolley, not by the wheelchair? No, trolley. Can you tell me anything that you think really make this project complicated for you or to you? Anything that you analyze with mathematical method by calculations? Oh, okay. All right, I think that's all from me. Yes, thank you very much, Anis. No, that's fine. That's fine. Where actually you now in Kampong in? Okay then. Okay, thank you very much. All right. Okay, assalamualaikum. Okay, assalam. All right, I'm done with Hanis. So I go next to who's next after Hanis?
Me, sir. Ni Arif Afnan, sir.
Give me a second. Wait. We got two Hanis, isn't it? One Anis Nadia. So another one with Anis Adriana.
Yes, sir.
So with me just now is Anis Nadia. Suhaimi.
Yes, correct, sir.
Okay. Then the marks goes to the different one. But anyway, I want to look into your presentation slide. Can you send it again to my email? Anis? Nadia? Okay, send to my email. So the next candidate or student will be Shazwan. Shazwan or Afnan?
No, sir. Ni Arif na.
Arif.
Me,
Ni
sir.
Arif.
Yes.
Okay, Ni Arif, please.
Okay, I will share my screen. So everyone can see? You can
Yes,
see,
I
sir?
can see. Development of
Yes.
automatic air cushion.
Yes.
All right, good.
Okay, Assalamualaikum. My name is Ni Arif Afnan bin Rosli. Okay, my supervisor is Sir Hisham Muhammad Reza. Okay, first the title of my project is Development of Automatic Air Cushion using Arduino for pressure ulcer. Okay, first, my project was same as a Ripple mattress at the hospital, but I have innovate or improve by putting a sensor turn on automatically. I also have made in form of cushion. Okay, starting for the block diagram, starting from input, load cell sensor will detect the weight of the user, and the data from the load cell go through to the load cell amplifier and directly send calibrate to the data to the Arduino. And then the Arduino will process the data of the user weight to control the relay of the air pump. Lastly, for the output, the LCD will display the weight of the user and also the status. And the air from the air pump will fill up into the cushion through the valve. Okay, for the flowchart, starting with the user weight, the load cell sensor will detect the pressure based on user weight. Okay, the data from the load cell sensor will be sent to the load cell amplifier to detect small changes in resistance and calibrate again the data before sending to the Arduino. Okay, then the Arduino get the first result, which is the user weight, and they check the condition of the coding applied into the Arduino, where is the weight between 1 into 30 kilogram. The pump will turn on about 50 minutes. Okay, after that, if the Arduino detect the weight of the user is about 31 until 49 kilogram, the air pump will turn on about 30 minutes. Okay, and lastly, when the load cell sensor detect above 50 kilogram, the air pump will turn on about 45 minutes. And lastly, if the load cell sensor detect no load or no pressure, the pump will stop. So the reason I set the weight 50 kilogram and lower because during sitting posture, weight distribution will get lower to half. The to half of the weight is distribute between leg and the body. My project work based on the weight of the user. The more weight of the user, the more time will turn on. Okay, this is my hardware that I use in my final year project. For the result and discussion, I use three different person. There is first my little brother. There is it show the weight of the of him and the status. And for medium is about 39.4 kilogram. And the sledge, my father, that is 58.3 kilogram. And the pump will turn on based on the status. Okay, that's all for me, sir.
Okay, so all right, good. So who's been tested here? Hard Rock Cafe. Is it your dad?
Yes, sir. My father, sir.
And the lady one with glasses? Your mom?
My sister.
Or your sister?
Yes, sir.
And your brother tested as well?
Yes, sir.
What are their feedback?
Their feedback just comfort sitting, sir.
Comfort sitting.
Yes.
All right. Okay. So before we go far, can I know? Actually, are you making bed mattress or chair mattress?
In form of cushion, yes, sir. Chair. Cushion, sir. Chair, sir.
Chair?
Yes, sir.
So if you use for a chair, I think it's in medical. I don't know which part actually applicable for.
Actually, in the back and the buttock, sir. The black
In
at the back
medical
and
practice, yes, in medical practice, normally that we use air mattress to
yes.
to move muscle, make sure they're not been they got ulcer on their muscle. So if you said that put on the chair, so I do not see anything that related to the design. So so you have to define well why you put on the chair.
Oh, because on this day, the people start to work from home, so it almost spend their time on the chair to do their work. So
Yeah, that
it
is
will
not that one we don't call. I believe no one having ulcer, pressure ulcer on the chair. Normally they have an ergonomic, they call ergonomic sitting or posture on the back side, not on pressure ulcer. I think it may be misplaced of your design.
okay.
So you should define well what actually you're going to tackle of your design, because the project idea look fine for me, and then showing the how the mattress, how much it cost to you, the mattress.
It's about 49 ringgit, sir.
49.
Yes, sir.
49, not bad.
Mm-hmm.
And where did you get it?
Shopee, sir. Just from Shopee, sir.
Shopee. Okay, they're
Yes.
available. Okay, if you tune for a certain condition of ulcer, skin or muscle onto a specific patient, normally they do this for elderly person or who having that stroke patient. So this is this they use for, okay, a mattress they use for. They don't do
Yes.
for cushioning when you're sitting, no, at all. What I heard and design in hospital. This is not for me. They use for to get comfy on sitting. Okay, so make sure that you're clear on that. Okay, so number 2, so what actually SMPS used for this project?
Actually, for this project, to convert AC to DC to power on the Arduino, because this pump need AC
From
power supply.
again, from AC to DC.
Yes.
Which AC to DC?
Okay, because the pump need AC power supply to turn on, so I just put one power supply to turn on the Arduino also, sir.
So you mean a pump need the AC or DC?
AC, sir, 220 volt.
Yes, I know, but there are many of a pump with a DC, isn't it?
But
So
it's not
why you don't use a DC a pump?
because it's not strong enough, sir.
Strong enough.
Yes, to pump and
So why the
because
minimum requirement to get the air pump into the mattress?
so I just choose AC because the airflow in the pump are also fast, and also so that's why I choose AC also.
And how
Because
much it
DC
cost to you for
when
the air pump?
for the air pump, I don't remember. It's just like
Okay.
50 below, I say.
50.
Yes.
Not bad. Okay, I think that's all from me. Okay, Nick.
Okay, thank you, sir.
All right. Okay, salah. Okay, Shopee dah. Okay, Assalamualaikum.
Waalaikumsalam, sir.
Okay, so who's next?
Me, sir.
Who's me?
Anis Adriana.
I'm Yasir now. Okay, give me 1 minute. I want to give a mark for Nick. Okay, so I'm going to get who? One. One sudah. Gila dah. Anis Adriana. Anis, are you there?
Yes, sir. But Akila Rukaya, can you present? Because if look at the name list, okay. Akila Rukaya first.
Rukaya first.
Because I thought her name is on the red list.
Red
So
list.
understand.
Whatever then. So Rukaya, you ready?
Yes, sir.
Okay, very good. Detection of uncertainty within medical refrigerator system. Okay, you can start.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Akila Ruqayyah binti Asaruddin. My supervisor is Dr. Muhammad Nur bin Nordin, and I have industry supervisor is Sir Nik Zaidi bin Nik Bulyamin. So my title is Detection of Uncertainty within Medical Refrigerator Systems. So I go to the methodology. The methodology consists two section, which is block diagram and flowchart. This is my block diagram. The block diagram have input, process and output. For the input is from technical survey and research from internet and journal. And then the process is analysis data, analysis from technical survey and research, and then it produce checklist and test procedure will be draft and doing the calibration testing to the medical refrigerator, and from the testing it obtain the data from checklist. So the flowchart. Next is flowchart. And the process will start to plan new work order, which is to draft how to draft the checklist and procedure, and then after the work instruction is done, we need to find an alternative to get the service manual of manufacturer service recommendation. And if yes, we can go through to do the checklist, and if not, we need to find the original international standard and other resources. And then we do the checklist. After the checklist is done, we find an appropriate tester to use for calibration and write the testing procedure. After done, based on the procedure, we run the testing. Then the result of the uncertainty measurement on medical refrigerator is obtained from the checklist. So next, we continue to the results of my research. This is a result of this document is the result of my research, which is the result from technical survey, and then the checklist that I create and testing procedure. Actually, this is a domestic refrigerator, not a medical refrigerator, because some limitation, I can go to the industry to do the testing for the medical refrigerator. So I just do it at home based on the checklist and testing procedure. I use data logger to calibrate temperature of home refrigerator, and the result is the result I obtained is pass. So the temperature
Pass.
of yes, the temperature of my home refrigerator is in range actually.
Okay.
So that's all for me.
That's all. I'm quite confused what actually you've done with your work for a year. Okay. So actually, I do prefer look into the data and how do you analyze from the data logger. So what the software you use
Software.
for the data logger?
Oh, the data logger use wait, let me touch.
So where's the result? You should show me the result. How you complement?
Result of home refrigerator, is it?
Yes. What do you mean of international standard? What kind of standard it fit to the what you say uncertain? So how are you going to fix it? Either they are automatic or not automatic. I don't know how this one can be declared as a FYP and then it work together with industry and what the industry said. What Nick Zaidi said.
This
Is it project match any calibration procedure? What you mean of calibration procedure and measurement checklist?
this checklist is used for calibration the temperature, which is
Actually, what you done with this one, I can't get anything. What you detect?
detect the uncertainty of medical refrigerator, which mean
You're
the
not detecting
error.
anything for me. You're not detecting anything. You don't prove to me anything on detection.
This checklist.
Where what tell you which one?
This the uncertainty of temperature. The uncertainty.
Yeah, you have to show when the temperature is not matched. So what happened to the system? So system should go do automated or not automated? Is it by manual? If by manual, why are you doing this work? You don't need to design it. So why you design it? Because it's a manual, isn't it? It's not automated. Is it automated or not automated? If they are automated, what kind of system? Where's the schematic? Where is the graph? I look, you done nothing for this one for a year. You waste of your time 2 semester. What did Zaidi say? What did he say?
He said that the result is okay to get based on this report.
Result is okay.
The result of this report.
So the result normally come out in engineering, at least easy to people to see with what? With graph, paper, is it match or not match, what you compare. When there's a lot of number of data, because you say you got data logger produce how many data you got? How do you run it? By hourly or by daily, by monthly, weekly?
By daily, sir.
So how many days you run for it?
5.
5 days. Okay, 5 days and versus to second or minute or hourly or what?
We need 10 minutes for certain location, and in the refrigerator there is some location. Okay, for certain location there is 10 minutes to stabilize the data logger to detect the temperature.
Yeah, I know what you're saying. So for me, it doesn't look like it's engineering design. It's not. So this like you put a sensor and then you read the data and nothing for me. I don't know how that Dr. I will talk to Dr. Muhammad Noor. So actually what kind of this work? I call him right now. Give me a second. Give me a second, okay?
Okay, sir.
Assalamualaikum. Macam mana? Busy ke? Okay, ya. Busy ke? Huh? Oh. Oh, start. Sorry, just 1 minute. Dia ni FIP juga ni. Your student ni, Akilah Rukoya. Dia macam blank je ni. So, this is not, dia kata dia sebut, this is not, she's not doing FIP2 actually, not doing anything. Okay. Okay. Yelah dia. Dia kata Nick happy dengan report dia. I said, where's the report? Show me the report. Show me some of graph. Or they do the apa ni, comparison. Okay. Tak boleh lah macam tu. Checklist kelab boleh buat. Okay. Yes, I can see that we're kind of putting some more sensor, data logger, software, then software, then you can produce anything that related that. Okay. Okay. Ya, data logger dah. Okay. Okay. Checklist pun kelabu je, tak tunjuk saya checklist tu. Okay. Checklist pun saya tahu pula boleh buat checklist. Checklist dah tahu ni suruh buat checklist. Dia kata Yalah. Kalau adjust sikit, kalau high impact punya title like apa COVID ke tak apa, like COVID punya vaksin temperature check ni, kalau buat macam orang tengok detection, kata you detect apa ni, tak detect apa pun. Certainly kena brief out lah actually apa yang certain kalau betul lah. Yalah. Standard apa pakai. FIP1 itu yalah, siapa yang itu access FIP1? Nanti tanya dia. Okay lah. Nampak dah. Okay, thank you very much. Okay, Assalamualaikum. Actually, who's your assessor for FIP1?
Sir Zubir and Madam Sabrina.
Sabrina. Do they advise you how to achieve or to be successful in this work? This is not research because I saw list that I heard you say research. I thought this is a research page. Actually, it's not research page. If research page, that you can come out a lot of data, and then you have to know, you have to pick the data, what they actually happening to the data, and you have to prove it based on the theory behind it. Okay. So I think, yeah, it's nothing here that I can see that I can judge you. I don't know, just a picture that's saying, I don't know if you did or not on this work as well. I can do this one in one night. I can take any pictures and then just scroll down at your page number 15, and the checklist. I know could be need Zaidi need the checklist for. It's very good for industry, but the checklist itself don't prove anything for your work. Okay? Akilah? Akilah?
Okay, sir.
Akilah.
Yeah.
So anything okay, you show me this here. So the refrigerator checklist. Scroll down a bit. Measure your amps. So this is your checklist by your own. Somehow people want to see the data logging original data from the software. So that one you have to come up with that analysis. Then you have to define actually what is uncertain, what the problem. That's why we call as problem statement. That came from that one. The problem came from uncertain, and you detect it, and they try to correct. This engineering trying to correct. Okay?
Okay.
Akilah?
Okay, sir.
All right, thank you. Assalamualaikum. Next, who's next?
Miss Siti Sarah Ibrahim.
Are you the last one?
No.
No,
No, sir.
Siti Sarah. There's a lot of people here. Faisal baru masuk ke? Anis, Adriana dah boleh left the room.
I'm not present yet, sir.
Ha?
I'm not present yet.
Oh, belum
That's
lagi.
Anis Nadia.
Anis Nadira. Ramai. Ni boleh ni lah, boleh keluar lah. Ni. Saya nampak ramai-ramai ni, saya ingatkan dah siap. Siapa yang dah siap boleh keluar lah. Pergilah makan ke, ngaji ke, dekat Zohor ni, standby semain Zohor.
Okay.
Zohor dah.
Sir, can you see my slide?
Yeah, I can see.
Okay.
Siti Sarah, I want to get your presentation slide. Mana? Siti Sarah, okay. Saya nak ni dulu saya nak. Okay, bagus. You put your name and ID, Ctrl C. Saya nak letak dekat Sarah Ibrahim, ID 512. Project title apa? Itu di sini development. Okay, body temperature. Control C. Saya senang, saya paste kat sini je. Pet medical supervisor. Who's your supervisor?
Madam Nazariah Muhammad Noor.
Nazaria Muhammad Noor. So next is okay, right, you can start.
Okay. Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Sarah binti Ibrahim and my supervisor is Madam Nazaria Muhammad Noor. Hello. Okay, I will present my project entitled development of controlling hypothermia body temperature. Okay, so here is my methodology of project, which is block diagram. Okay, as you can see, thermistor and humidity sensor will be the input, and then then will process by the Arduino. And lastly, the output is PTC air heater and blower fan, and the readings will display on the LCD. Next. Okay, next. So this is the flow chart of the project. Two sensors that been used, which is thermistor and DHT22 or humidity sensor, will collect the data and process in the Arduino. And if the body temperature less than 36.5, the relay will turn on just like a switch to filter and let the power from wall plug flow to turn on the fan and heater. They will maintain patient temperature within 36.5 to 37 degrees Celsius. Then the LCD will display reading of body temperature, air temperature, humidity temperature, and status of fan, either on or off. Okay, this is hardware that has been used in this project is NTC thermistor to measure patient body temperature, DHT22 to measure humidity and air temperature, Arduino Uno LCD to display sensor reading, PTC air heater to heat the surface, and DC blower fan to spread heating generated by PTC heater. So this is my final result. Actually, at the top of the prototype, thick rack will be placed and act like a mattress, and the heat generated from the heater and fan will spread all over the surface. A thermistor will be placed on the back of the patient body to detect body temperature, while humidity and air temperature sensor will be placed on the front of the project to more easily monitor the humidity and air temperature. I put the heater and fan in the PVC pipe to ensure the hot air reaches the entire surface. That is how my prototype works. So this is the line graph from the subject after taking data on room temperature and air conditioning room temperature. The purpose of the data taken is to test the functionality of the thermistor in this project. From the room temperature, it shows in the first 10 minutes, the thermistor managed to reach a temperature of 33.6 degrees Celsius and constant the temperature, finally able to cut off and back to 33.3 degrees Celsius. While at air conditioner room temperature, the graph also shows the same trend. The body temperature is getting lower due to the cool temperature. The first 5 minutes, the temperature reaches 30.2 degrees Celsius and is able to constantly cut off. Okay, as you can see, the body temperature in the air conditioning room is lower than the body temperature at the room temperature based on medical news website entitled The Best Way to Reduce Body Heat. The human body responds to external and internal changes. Body temperature rises when the external temperature rises, but also when the internal temperature rises. So it is normal. Requires a time interval of 5 minutes for better and accurate results. So the conclusion, I managed to control and maintain patient body temperature by controlling fan and PTC heater, and able to measure body temperature using thermistor and to analyze the effectiveness of proposed device. So for the future planning, this project can be improved by adding a function to control the temperature by hypothermia sufferer, which is patient who produce more heat than they lose, and can be improved wirelessly by using IoT. Okay, that's all. Thank you.
Okay, thank you very much. Siti Sarah.
Yes, sir.
Yes, Siti Sarah. Do you have got number hypothermia patient in Malaysia?
Number what, sir?
Patient.
What do you mean by that? Patient that suffer for hypothermia?
Yes. Have you got anything data from KKM, for example?
No, sir. I don't make the research from that, but mostly patient people will suffer for hypothermia during the surgery.
During the surgery?
Yes, sir.
Okay. So I just want you to spot out actually your case of some of industry or hospital that they think that your design might be really useful for them. This is what I mean. Okay, if you say that, so what kind of surgery they find suddenly patient temperature goes down very quick?
Cardiac open heart surgery.
Open heart. Okay. Um, so based on okay, if they said that is it that you think I look your design is look like designing the OT or OT temperature, is it true?
Yes, true, sir.
Okay, so if I am the surgeon, I found that room quite low, so what I need to do to increase the temperature from in the room?
Temperature, air temperature in the room. What do you mean by that, sir? Sorry.
Okay, all right, straightforward. Okay, if I'm sitting in my room and I found my room really cool, what do you think that I will do?
If you're very cool.
Okay, for example, if your room really cool, if your room very cool, then what you do? Your room have the air condition, because normally in OT they have air condition or they use a fan.
I just slow down the temperature.
Yes, exactly. So why they need your design? Then you have to stand with your project, because you work for this one for 2 semesters, don't you?
Yes, sir.
2 semester, 2 months or 2 days? Huh? How long been work for this?
Around 2 months.
2 months, but the
2 or
university
3.
give you time for 2 semester, but you only did 2 months.
Yes, sir.
For
Okay,
me,
sir.
university put the wrong timing for the student, FIP2 student.
Okay.
Get back to the questions, because I'm thinking of, I know what you are doing, because I think Nazaria got a lot of idea and trying to solve the ICU problem. Okay, but I think probably not really understand what actually you're doing.
Okay, sir. Actually, this device is for patient that suffer for hypothermia during the surgery.
Okay.
Okay, means that this device is actually small. It can detach and attach to the bed. It will be attached under the bed, and then it will flow the hot air to the left, right, and bottom side of the bed. Okay, and finally, hot air will be flow to the patient, and can can cover the top of the patient with a reusable blanket to trap hot air. Because during the surgery, hypothermia will occur primarily due to a combination of the thermoregulatory control disturbance caused by anesthesia, cold room environment, and surgical factor that cause excessive heat loss. So that is why my project is to control the hypothermia sufferer, controlling their temperature, to maintain their temperature.
For me, you still can't show me that your work can controlling that body temperature.
So I can show you my demonstration video.
has been downloaded to uploaded to Teams?
Yes, sir. I already
Okay, I will
upload.
look at later. Not to worries. But I want you to stick with your idea. So actually, you done with the work actually. So if you say you're trying to controlling body temperature with the wind, is it true with the wind?
With the wind, yes.
I think it's nothing that can work as logically if you present to non-medical background. Okay, even to anyone that you say the best answer they will say easily as just put down the temperature of the aircon, so all done. So why you need the complicated of sensors and blower and heater to heat the room?
No, it's not. It's not to heat the room. It to heat the patient, sir. Patient that undergo the surgery.
Heat the patient?
Yes, heat the patient. Patient that undergo the surgery will be given the anesthesia. So hypothermia can occur during that time, during surgery.
Okay then.
It's not about the room.
So the first and ask you say just using the blower, and then the secondly you stick with how what the element that to heat patient.
PTC air heater. I combine it with the fan, so the fan will spread the heat. It just like a hair dryer, sir.
Yes, I know, but that's why I told you. So for me, I can see the lack of your work. Actually, the design of how to attach temperature next to the patient, straight away to the patients. So that's the thing you should design, like automated blanket or even though in the market they have the blanket warmer already then. So I think as a surgeon, so they know what they are doing, because for me, you cannot prove that your work actually really can solve medical design in hospital. Okay.
Okay, sir. But sir, my project is automated.
Automated, yes, I know. Okay, my human. How do you going to attach? Okay, I give you straight away the suggestion. How? Okay, my first suggestion with a blanket. Number two, you put some filament attached to the skin. That much more quicker rather than you put on as an air blower. Air blower can't do nothing, just a surface. The body heat, body won't increase. I think the nurses in the room and the surgeon will get hot quicker than the patient. Do you know what I mean?
Yes, sir. But I think you can imagine my project, sir.
Yes, I can imagine. So that's why I asked you what the element. You said just even the design also stated here. You just use a blower, the wind, and air heater. Air heater that produce heat into the room, and if it's the surgeon will get sweating, and then he or she might be not comfortable doing the surgery. Okay.
Okay, sir.
All right. So that is the thing probably you can put into the what as future
future planning recommendation.
Yes, your recommendation, anything you can improve. All right, thank you.
Thank you, sir.
All right, thank you. So who's next? Who's next?
Miss Hanis Adriana.
Are you the last one?
No, sir.
Anis Adriana. Tasnim dah kan? Tasnim?
Dah sir, dah.
Masih berminat lagi untuk ada kat room. Siti Sarah dah. Sazwan dengan Faisal lah belum lagi?
Yes, sir.
Okay. 3 orang lagi. Saya nampak macam ramai je. Kata bila nak siap ni?
Support member.
We have another 3 beside Hanis Adriana.
Sekarang Ana Suha ke?
Bukan, saya tak sekali.
Ni Adriana.
Yep.
Okay, you can start Adriana. Wait sekarang. Saya nak copy yang ni dulu. Apa ni? Markah dulu. Okay tunggu sekejap. Okay, Anis Adriana. So saya rasa sudah ada ni. Anis Nadia. Muncullah Anis Adriana. Masuk ke Mansur? Your dad?
Masuk.
Masuk.
No N. Masuk no N. No N.
I think masa registration dia orang tersalah type Tak tanya ayah juga?
Tak.
Tak
Memang
tanya
macam
Yalah, sometimes masa saya zaman-zaman saya dulu, kadang-kadang yang nama pelik-pelik ni, polis ke orang registration dia tersalah ni, dia tersalah apa? Dia tersalah taib. Sudah ID, you tak tulis ID you berapa? 512? Cuba baca.
51215. 5121511 8104.
10 8104.
Yep.
Okey, berapa? Belakang ada 4 ke?
104.
Supervisor?
Sir Syahrizaili Mukhtar.
Okay, can start. Yang ni Haji punya ya?
Yes, sir.
Kita terus pergi dekat ni, metodologi. Okay. Project lah. Cepat-cepat, nak pukul 1 dah ni, ada 3 orang lagi.
Can you see my slide, sir?
Yes, I can see. Just carry on.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Hanis Adriana.
Okay, Anis.
My supervisor is Sir Syahrizaili and my industry supervisor is Ustaz Abdullah Faisal. He is a professional mutawif and he lives at Puchong.
In Puchong, not at.
in Puchong.
Yes.
Yes, first thing first, this is the hardware I use for my project development. As for the input, I use MLX90614 infrared thermometer sensor for body temperature detection and water sensor level module as for skin hydration. For both of these parameter connected to the microcontroller ESP not MCU, which is act as a processor and coordinator from the sensor to the user phone. Then the phone will give the output through the Blink application and cloud server. Next, for my project flowchart, when the product is turned on, the temperature sensor and skin hydration sensor will start to measure as we place our wrist part at the sensor, and then the temperature sensor will detect our body temperature whether it is high or low. Meanwhile, for the skin hydration sensor, it will start to measure the total water, measure the percentage of the total water in the body, while for the woman, the healthy range and normal is 45% until 60%, and for the man is 50% and until 65%. After that, both data will send through the microcontroller, then will be displayed to the phone apps, which is Blink application. So this is my video demonstration. So this is for the dry situation. I do for two situations, which is dry and moisture. For the moisture, I apply lotion. This is the temperature reading, and this is for skin moisture. The next part, I apply lotion at the wrist part. So this is the reading. So from the result of the video, you can see that the body temperature for the dry situation, which is without lotion, is 36.6 degrees Celsius, and for the skin hydration is 40.3%, which is the body temperature for dry situation is higher than after applying lotion as for the moisture situation. This is because when we apply the lotion, it helps our body become moisture and cool, so the temperature will drop. While for the skin hydration, while for the skin hydration, according to the chart below, it shows that the result of this percentage is below than the average health range for women when in dry situation, but it rises a little when in moisture situation, where after I apply the lotion and reach the average healthy range. As for the conclusion, throughout the entire project, all the objectives of the project were met. my project development can help save a person life because early detection alert them before they have serious problem health. Other than that, this project development would be useful to other industry, not just pilgrims during Hajj and Umrah. Furthermore, it can be used to other industry, for example, sport industry, for athlete used to training and monitor hydration level during competition. So for the recommendation, to make a recommendation, first thing first, I need to reduce the size of my project development as it intends to be worn on the human body. Thus, on a final development scale, it should be the size of a marketable watch or other wearable. My idea first is to make a wearable monitor e-health monitoring because for the prototype I use ESP32 is big and the prototype is quite big as a wearable, so I need to change the hardware into the example ESP32 to Arduino Nano because it is smaller. And other than that, the casing for the product I should develop with water resistant material, so it can be used such as in a rainy day or maybe we can move anywhere. Plus, the way it notifies the user should be improved not only by sending notification through smartphone, but also adding an alarm with vibration. It also can help impair user.
Hanis, can you go back to your design? The video that's showing the prototype, is it what is size of prototype?
The size of prototype, I should the idea is to make such a wearable watch like smartwatch.
Okay.
But
so that one can be inserted into the pocket.
Insert to the pocket, yes, and also to bring anywhere. It's easier for us to move.
So basically, the sensor sensing what? The air temperature or the skin temperature?
Skin temperature.
Skin.
Yeah. Body temperature. Skin.
I think the power bank temperature will make the sensor trigger to the higher degree. So not the body. So how to determine that, because it look like the design on that way, isn't it?
Yeah. So maybe I should change the power bank to the battery and charger. So my project.
That will be not safe for me. The recommendation will be like you should do like we call as we use just a tiny power to use a sensor. Okay, so it will not be harmful to the user itself. For example, that you can use watch a battery, for example. Okay, two plate of a battery. Then you have to use a very tiny of sensor that can sense. Okay. By the way, this is a good design, and for me, it kind of useful for foreigners or visitor to Mecca, since some of our community, our community pilgrim, not really aware. Some of them got first time in the Saudi, isn't it? And then they don't aware, they can't imagine how the way that it is. So this kind of idea is good for me. Then for me, just a design of prototype quite bad, okay? Because it's a huge, and the sensor you use not really sensitive, and the lotion you use as experiment not really make sense to the design, okay? Rather than you do experimental on drinking, normally the hydration goes to the drinking. The people will turn to the drinking, how the water drinking that can make the difference on the sensor, something like that. That makes sense. Rather than you put lotion on that, so I don't think that it can show or prove anything. Okay, Anis.
Okay, sir.
All right, then. Thank you very much.
Thank you, sir.
Okay, thank you. Assalamualaikum. The next one, who's next? Who is this?
So can you hear me, sir?
Yeah, I can hear you. Why you don't use your mobile? PC.
Sorry?
Why you don't use PC?
I'm using my PC. The phone for the microphone.
Oh, the phone for the microphone. Oh, okay. Quite
Laptop mic is
innovative.
problem.
Okay, give me a second. I want to submit Anis marks and experimental with. So, you dekat mana? Siapa sekarang dengan saya ni?
Dekat mana?
You Faisal lah.
Faisal. Dekat bilik lah. Kat rumah.
Oh, where's your rumah?
Kuala Langat.
Kuala Langat.
Aha.
Oh, Kuala Langat. Kuala Langat dengan Hulu Langat lain ni?
Sorry, sir?
Kuala Langat dengan Hulu Langat lain ni?
Lain. Jauh.
Jauh. Saya dah pernah, saya dah biasa pergi Hulu Langat ni. Kuala Langat ni yang highway tak sesiap tu ke? Yang tu ke?
Dah siap dah. Dah siap dah.
Nampak bubuk yang saya tengok itu selalu pergi ke Perak, lalu kat belakang dengan berlubang-lubang dengan batu putih tu banyak pada tar je. Buruk sangat lah tempat awak ni.
Itu bukan Kuala Langat.
Itu mana?
Itu yang kat skin check tu kan?
Itu apa nama tempat tu?
Itu
yang highway tak siap tu.
Itu lah. Tak pernah siap berapa tahun dah.
Itu highway mana?
Itu highway. Itu highway apa dah saya tak ingat.
Itu bukan highway kan? Dia macam apa ni? Dia macam jalan kesetuan ke jalan negeri
Saya balik kampung pun ada situ tak?
Apa nama tu? Tempat tu? Tu?
Kinchan tak silap ni.
Ha?
Kinchan kalau tak silap.
Sekincan lah. Sekincan tu itu Kuala Langat lah, bukan Kuala Langat. Itu Kuala Selangor lah.
Tu Kuala Selangor.
Apa beza Kuala Selangor dengan Kuala Langat?
Kuala Selangor belah utara, Kuala Langat belah
Selatan.
barat. Hulu Langat timur.
Oh gitu. Yalah. Tak ada apa benda sangat kat sana, so saya jarang pergi ke sana. Kenapa teruk sangat wifi kat Bemai? Dekat rumah you. Okey, kejap saya nak ambil ni your Faisal. You submit dah tadi kan? Faisal, Ruqayyah, Tasni, Afnan, Hazli pun ada ni. Syazwan. Tak ada pun. Syazwan, Siti Sarah, Nasuha, Tasnim, Fakro. You tak submit PDF?
Submit kat mana tu?
Email saya lah.
Tak.
Lah, kenapa tak submit?
Saya masuk lambat tadi.
Astaghfirullahalazim. Dah macam mana ni? Macam mana saya nak tengok? Hantar sekarang lah. Okay? Hantar sekarang, buat dulu. Because saya akan tengok kat sini. Ada dua benda saya nak simpan as evidence.
Okay.
Ada kunci love ni lagi ni. Atau apa, hantar ke saya. Then next lah. Syazwan lah. Start dulu. Syazwan.
Okay. Sorry, sir.
Tak apa.
Sir, I have sent the new slide to you. I have yang file tadi saya salah.
Slide. Salah pula. Okey lah, tak apa. Okay, Syazwan.
Okay.
Syazwan. Okay, slide. Development of robotic aromatherapy. Aromatherapy ni.
Okay.
Belum sabar lo. Saya kena copy your name. Terus C.
Saya send yang baru tu, sir.
Yang baru ni lah saya ambil. Paste, ID. Banyak ni kerja sebelum buat, nak kena record kan. Sekejap. 18 minit nak suruh dah. ID tak ada tulis ni. Okey, tulis siap-siap kat sini. Senang saya copy. Project title. Ni tadi nama apa? Syazwan. Syazwan buat macam ni buat macam apa? Macam Syazwan ni. Terus letak situ. Janganlah pakai hantar je. Boleh nama, ID, project title, 3 benda lah. Senang saya nak copy kat dalam ni. Rubrik ni. Okey. Project title dia tak? Tulis tak?
Ada kat atas. Kat atas.
Okey. Kan senang. Okey, electric medical supervisor. Your supervisor siapa?
Siti Afifah binti Moshim.
Okay. ASM. Okay, you can start with methodology.
I forgot to share my face.
Forgot to share your face?
Yeah, open cam. I forgot to open cam.
Apa?
Okay, sorry. Okay, I proceed.
Yes, please. Okay.
So can you see my slide?
Yes, I can see.
Okay. So, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazam Ibaruddin and I will proceed to the methodology. My project title is the development of robotic aromatherapy air humidifier using Arduino. And my advisor is Siti Afifah. So, this is the main hardware. I'm using rechargeable battery, DC motor, Arduino Uno, DHT22 module sensor, SDC display, heater plate, and ultrasonic mist maker. So this is my project designs with casing. So this is the circuit diagram. So basically this is how my project work in the software. So when you can see the relative humidity, if below than 49, below than 55%, so the humidifier in the red LED and the yellow LED can turn on. So when the temperature more than 34, the heater will when the relative humidity is up to 55%, the humidifier will turn off, and the temperature if below than 24 degrees Celsius, so the heater will turn on. So the block diagram is for the input is rechargeable battery. The process is Arduino Uno, DHT22 module sensor, and the output is DC motor, ultrasonic mist maker, LCD display, and heater plate. So I will explain in the flowchart. So first, start the power source, which is rechargeable battery, and when you press the button start, it will automatically turn on the motor, and the DHT22 module sensor to detect temperature and relative humidity, and then send to Arduino Uno. And LCD display will show the value of temperature and humidity value. And if the temperature is below than 24 degrees Celsius, it will turn on the heater. And if higher than 24, it will turn off. And then after it depend on temperature, it will detect the focus on relative humidity. If it below than 55%, it will turn off the autonomous mist maker. If it's higher than 55%, it will turn on the humidifier. And then it will also depend for the daylight. So if for 9 a.m. to 6 p.m., it will turn on the lemongrass, the lemon scent water mist. And if when the night, it will turn on the lavender sand mist. So this is the result for if the relative humidity higher than 55%, it will turn off. If the relative humidity is below than 55, it will turn on the humidifier. If the temperature is below higher than 24 degrees Celsius, the heater plate will turn off. And if below, the heating plate will turn on. So as I said earlier, the day and night water mist, it will change depend on the time. So the discussion is based on my objective, the project can move around and change direction if it's bumped to the wall. As you can see, I have shown in there is a video. And then the project change the different sense depending on the time and will turn on mist when the relative humidity is below than 50. The heater will turn on if when the surrounding is below than 24 degrees Celsius. And for aromatherapy, there is two different scents, which is for the day and night. For the day, is lemongrass or lemons to make us stress-free and more energetic. And for the night, is lavender to make more calming and easy to sleep. So for my conclusion is, so this project is beneficial for people with respiratory problem like asthma or skin problem like eczema. The humidity temperature surrounding can be maintained, and the aromatherapy scent for physical treatment during the day and night. For further research, I would recommend to include additional sensor such as ultrasonic sensor, so it will stop the direction before it bump to the wall. So I would recommend to increase the speed and add the additional notification display such as power the power level of the device.
All right,
So
then,
that's all.
okay.
Thank you.
Okay, very good. All right. My first question. So your prototype or your design, okay, look fun for me. Then which of the design that really reflect to medical electronics?
So basically for the mainly is for the air humidifier and the heating plates. Can you hear me? Hello.
Yes, yeah, I'm listening. Yes.
Basically for my main feature is for the air humidifier.
Air humidifier. So what the air humidifier do benefit to patient and related to hospital?
So basically, when the based on my research review, so when the air is drier, which is the relative humidity is low, so when the data is less, so the fine dust in the air will spread around the air. So when the surrounding humidity is humid, so the air will fall down to the in the floor. So basically for people who has asthma, who cannot breathe with fine dust. So they will help this problem. Same also for patient with eczema. So they cannot handle with dry air, as their skin are so sensitive. So this will also help for patient like that skin problem.
Okay. So the design, have you got any data that can be added into your design analysis?
Sorry, sir.
Your design analysis, any data can be added into I mean into your work,
So
data or theory behind it, what the application do.
So I did a survey for people, which is so I did a survey for people. So when as I said earlier, my project is have the aromatherapy sites, aromatherapy fields. So detect is how they feel before they using the ultrasonic mist maker. So if as you can see here, so if they need to rate their stress level before they using the lemon stress, the lemon essential oil. So as you can see here, for the day, most of them rate 3, 4, and 5, and after they use the product, use the water mist, so there is stress level. For the my project is moving around, so basically to move.
Can your robot sweep the floor as well?
Yes, actually. Do you want to see the video? As you can see,
to press the button start.
Yes, you can
and
see
the project will start moving.
There is a fan that will rotate the swiper. Yes.
Okay then. I think that's all from me. Okay, Shazwan.
Okay,
Very good.
thank you, sir.
Okay, thank you. Bye. So we go to the last one. Is it Faisal the last one? Faisal. Anaswar ke? Anaswar.
Anazar belum.
Belum?
Belum.
Oh, saya ingatkan Faisal last. Okay lah Faisal, present.
Okay. Sir, I've sent my email. Did you get it?
Yeah, I got the file. All right, you can start.
Okay. I'll proceed to the methodology of the project. There are 3 parts, which is hardware, software, and project design. And there are 6 hardware that use for this project, which is CMG electrode, EMG module board, FSR sensor, which is force sensitive resistance sensor, Arduino Uno, and for the output is RGB 12-bit ring light and servo motor. The software used is Arduino. This is the project design. First the patient muscle, and then at the above is the surface electrode, EMG V3 mode, data display, and also servo motor. The second one is for force sensitive resistance, and the interface will be Arduino also, and the output also servo motor and RGB ring light. This is the actual project. The block diagram. The EMG sensor and FSR sensor acts and the input, and the Arduino Uno act as the processing part, and the output will be real-time display graph EMG. Three movement for the output of the EMG sensor. 1 and 2 is the motor, 2, 3, 4, and 1, 2, 3, 4 is the motor movement. The three movement that motor move is thumb and index, gripper movement, and all movement. Which is motor 1, 2, 3, and 4. The movement will be all finger movement for the handshake pattern. This is the flow chart of the project. The first one is to initialize the muscle sensor, get data from sensor. Arduino software will detect the two different electrode reading to perform a single movement. As you can see, the three movement is in sequence. First one is for all motor, which is 1, 2, 3, and 4. The second one is for motor 1 and 2, and the third one is for 2, 3, and 4. For the FSR sensor, it will initialize data from the FSR sensor, and the output will be gripper for handshake, which is all motor, and also ring light. As per objective, the first one is to develop a prototype of prosthetic arm using the EMG sensor. That is the first objective, and the range of muscle on the analog reading level is around 100 and 150 based on the patient itself. Motor 1 and 4 is for the thumb and index finger, which is this one, motor 1, and motor 4 for the thumb and index finger. Motor 2, where's the mouse? Motor 2, 3, and 4 for all finger except the thumb. Each motor will give 90-degree angle output. Due to the skin electrode placement of the skin, there will be resistance in the electrode that also have a slide on the output reading signals such as air gap or unclean skin surface. The result type of movement, thumb and index, gripper movement, and all finger movement. For the result in discussion 3 is to display a specific real-time data of the electrical muscle activity via Arduino software. This is the analog reading of the muscle when the muscle is relaxed. The data is 135 in analog reading, and when the muscle is contract, the data give up to 140. This is the result and discussion for the FSR sensor. A reading of the pressure sensor can be monitored based on the analog reading also. This method applied on the handshaking technique pattern where the other person will apply the pressure to the sensor. Which you can see the sensor is here. Do the handshake pattern. The other person thumb will place here. Okay, each motor will give also 900-degree angle up to 135-degree. Result will remove all the motor to produce the handshake pattern. For the conclusion, mechanical part of the prosthetic arm has been developed successfully with a minor problem, such as the return movement of the finger itself. The second one is all motor have been moved as per stated, objective achieved. The third one is reading of the data has been displayed for both input activities, which is the muscle sensor and the force sensitive resistance sensor. Then the last one This project will be a huge impact to the society to spread this positivity awareness towards the disabled patient with arm disability around us. For the further research on how to control every single movement with few developers that that develop the sensor that can detect the muscle activity, various muscle activity to produce various output, but it will cost a lot. The second one is output data can be currently displayed on the serial plotter on the Arduino software. For the research, we'll be displaying the data using cloud such as Blink, etc. The third and the last one is output data can be automatically stored as a database for the future reference for the patient. That's all. Thank you.
Right, Faisal. Okay. Okay, my first question. So you actually working with this is a wireless EMG sensor for disabled patient, or what kind of that?
No, it's not. It's not wireless.
It's not wireless. Means that if disabled patient, can you justify who actually disabled patient?
The person that lost their arm, their lower arm.
Lower arms. Okay. So why they need this prosthetic arm for? I mean your design, your work.
Because to ease their daily life tasks, which is, yeah, we know we
okay.
handed
to handle what?
If the patient use only single-handed, then there are limitation to do the daily task work.
Okay, so I know. So at least I want to know that you you really understand what is your objective. So how many objectives you got?
3.
3.
Do I need to repeat, sir?
Hmm?
Do I need to repeat the objective?
No. I'm reading it. No need to repeat.
Oh, okay.
So what actually real-time data really useful for your design?
And it can be monitored by the patient also to know their ability of the muscle, whether it works or not.
Okay. Do you think that disabled person able to understand of the data?
Yeah, because the data is really simple that uses analog reading, just analog reading. If you can see on the previous research, most of the data use in millivolt reading. So it's quite hard for the patient to understand.
All right. I think that's all from me. Any question from you? Okay, for me, you have done work very good. All right, overall. So then you can answer the question well as well. even for me, your applications is not definitely goes to disabled person, but for me, that at least can comply to your FIP2 and reflect to your program. I think that's all from me. Thank you. Assalamualaikum. All right.
Do you do you have any suggestion for the project?
Yes, of course. So you need to upgrade to quality sensor rather than a flex sensor is ages. It's been not really for me good as we got today. For the arm, probably you can use 3D. You can use 3D printing 3D printer. Okay, 3D printer to print out rather than you use a wooden hand that people can imagine. Is it the you trying to show like a wireless one or something like that? So that's why I'm asking. If you do that, will be much people can see, because I realized many people have done this work similar to you, but I didn't see any difference of that. So that's why I can say that since you can present well, and then you can show some of engineering words inside your FIP2. I think it's a good for presentation. All right. Thank you. All right. Assalamualaikum. So the last one, Anaswa, isn't it?
Yes.
Okay. Anaswa.
Wait, now doctor.
All right. Please. Oh, you. Anaswa. I'm quite confused. I thought the Anaswa had another one. Okay. Yes. Can start.
Wait, doctor. Tengah buka ni slide. Loading. Can you see my slide as well? Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Anaswa Teacher Senu and my final year project title is Classification and Data Processing for Patients with Alzheimer. So we will proceed to the methodology. Okay, for overview research design, the data include collected result record from the execute study to discriminate the future assertion, then the identification of Alzheimer classification is met. The output of research design is the develop of early detection method for Alzheimer disease and alternative early detection classifier. This is set as the planning to achieve objective with the effective educational involvement. Following the collection of the data, will be developed by machine learning to produce the most successful classification system for the research. So, software. This is a software that I have been used. Sorry. Which is PyCharm, Sklearn, and Excel. This is a machine learning algorithm that has been used in this research study, which is SVM. SVM support vector machine typically used for classification tests with the high dimension data and are allowed for us to classify data that does not have a linear correspondent. So CanN is an algorithm assume that similar things exist in close proximity. In other words, similar things are near to each other. So the lastly is decision tree. Decision tree is for analysis involvement making a tree shape diagram to chart a course of action or statically probability analysis is used to break down complex and problem of the branch. So
This is my flowchart. Following the flowchart framing of the model, a review of SVM, CAN-N, and decision tree with randomized parameter model will be made depending on each model ability to do good in classifying activity. As a result, the best way to classify activity will be determined. Yeah.
Sorry, I'm talking to my kid. Sorry.
Okay. As a result, the best way to classifying activity will be determined by the most excellent classifier and parameter that will be used to classify activities. So this is present data, graph data. This is the current data is for pre-processing EEG recording for 49 people involved of Alzheimer and
Wait a second, how many people?
49 people of Alzheimer.
49. How did you get all of those sample?
This is from the previous study.
Previous study?
Yes, this is from the previous study that I have collected from FISCON.
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 The research name is FISCON.
The data from online.
Yeah, from his previous study. Maksud, by mean that his previous research. So I just get the data from him.
From Dr. Zo.
No. From the research. From this researcher.
From researcher.
This
Who's
data,
the researcher?
Okay, this data I got from the research article.
Okay.
Research article. His name is FISCON.
Okay, all right.
So this is pre-processing EEG recording from 49 people involved with Alzheimer and 23 for healthy control. Okay. This experiment employed.
Wait a second. Wait. So do the what the name? FISCON?
Yeah, FISCON.
So you got the data from the paper itself. They supply the data.
Actually, there is someone have used his data to do this to do the classifying for machine learning too. So I got the data from the online. They upload the data at the online.
Okay, can you specify which the address, which website you went to?
I went to the GitHub.
GitHub. Okay, so that's why I'm so. Normally, paper they don't publish the coding. I mean the data, the specific. They might use a single data, not the full list of 49 patients.
Yeah.
That's why I'm thinking of probably you got it from Dr. Zo.
Oh no.
No.
I just went by myself.
Okay.
Okay. So as you can so where we are. Okay. I already told you that this contain of 49 people of Alzheimer and 23 health control kan from the FISCON study 2018. Okay. This is my outcome for result and analysis for my outcome is evaluate the optimum classifier for Alzheimer and healthy control. So the table display the accuracy of main type of machine learning classifier or algorithm such as SVM, CAN-N and decision tree. Linear, as you can see, linear achieve an accuracy of 0.5924 in SVM. The measurement of sigmoid accuracy is 0.9439 and the obtain of polynomial accuracy is 0.7136. These three kernel have a lowest accuracy compared to RBF. which has a higher accuracy around 0.7393, although CanN and decision tree produce an accuracy 0.955. This is unfortunate result. So this is the data that have been collected through the Python machine learning. Okay. From the result of classifier accuracy value that change as parameter are changed for algorithms that specify accuracy data were obtained by testing from parameter 1 to 21. This procedure is to perform to obtain the best accuracy for comparison and selection by change the kernel and the value of C parameter for SVM and K parameter for CanN, K neighbor. As for DT decision tree, you can change for the depth value. Okay. For outcome to optimize and analyze the parameter within the classifier for Alzheimer disease and healthy control. So this is accuracy of SVM model in C parameter range at C21 in Excel and Python. SVM create a various accuracies.
Okay, you go to the next page, next slide.
Next slide is discussion, sir.
Okay. All right. Yes. Okay.
Okay. SVM create various accuracy results since the C parameter varies depending on kernel and the maximum expected accuracy of RBF model for Alzheimer and healthy control classification was achieved by C parameter at C21 with the value of 0.394 due to the large number of accuracy than the most C parameter and the other machine learning. Each time the model perform, the accuracy for each C parameter measure will be slightly altered and based on the way the data split, 0.3 is equivalent to 30% test. So for the discussion, the Python common code is used to start given program by directing the Python file. These outcomes are examined throughout the research objective. As previously reported in previous study, decision tree is stood among the other parameters that provide greater accuracy in terms of classification output. Although SVM has a lowest accuracy that researcher has used its polynomial kernel are construct by taking parameter the polynomial kernel function of C2. So he just take polynomial kernel at C2 only. To prove that SVM is better or which is machine learning give good accuracy, then overcome by testing and collecting the accuracy data average of each kernel, such as linear, RBF, sigmoid, polynomial, and differential C parameter, and using CanN by turning the K parameter and also decision tree machine learning too. So as conclusion, SVM, through the first objective, we can predict that SVM model is the best for investigating different machine learning technique for Alzheimer's disease, as the accuracy of RBF kernel that greater than CanN and decision tree with a contrast accuracy of 0.7394. Furthermore, secondary objective is accomplished by determining optimal parameter with classifier for Alzheimer's disease and satisfactory accuracy is produced as the result of operation. So this model will assist the clinicians in identifying key features identified with the diagnosed neurodegenerative disorders in curing suspected infection as a result of classification issue. So for features recommendation, the input data for research can be gathered for associate related to Alzheimer's disease. Second,
I think that's all. All right, Anaswa, I think enough for the recommendation. No needed.
Okay.
Okay. Just answer my questions. Okay, can you explain me the KNN advantages of using KNN in classifier?
Advantages.
Yes.
But
This method has been introduced around 20 years ago. So probably why people still doing it? Probably they have some of advantages of using KNN using for machine learning.
In this study, I just select my SVM as to prove that it's better from the KNN.
Yeah, I know. So, but you still comparing, isn't it?
I have compared the SVM, KNN, and decision tree. So this tree of machine learning. So from all of the machine learning, I have been selected based on the accuracy that I get is SVM give a good SVM parameter.
Yeah, I know, but KNN still good in machine learning. So what the advantages using KNN?
Advantages of using KNN rather than SVM or rather than
in your work, in your project, or KNN in investigating or to train the data. Why KNN is a good is a good competitor or comparison to. How about the decision tree? It's much more longer than KNN. I think they found KNN at decision tree around 30 years ago or 40 years ago, based on paper, isn't it?
Yeah.
Okay, so just show me some of advantages using KNN.
Advantage of...
Are you using a MATLAB?
No, I don't using the MATLAB. I just use Python.
Python. Okay.
Yeah.
Any advantages of KNN?
Advantages of KNN is can be applied to the data from any distribution. For example, data does not have to be separable with linear boundaries. Very simple and intuitive and good classifying in if the number of a sample are larger good enough.
Okay, very good. Which website you refer to?
I just refer to the article that we talk about the KNN and also decision tree just one by one.
Okay, that's fine. My question back to your work, actually, that's fine. But I don't like you understand what you're doing. That is the most important for me. Some students, they investigated on machine learning, but they don't know what kind of work they done, something like that. That's fine for me. Thank you very much, Anaswa. Any question from me? For me?
As you can see that I really understand my project or not.
You do, but not as optimum as better, but it's fine. So at least you learn. This machine learning quite popular currently for signal processing, research, and it's really good for you if you want to further your study for a master, for example. I got some title for machine learning if you're interested for the master program.
Oh, okay.
And then you can just continue this work and then you can finish within 1 year.
Oh. Tapi but just for my research is just want to prove that my Fiscon just want to prove that Fiscon is wrong by using SVM. He just used only one parameter to prove that SVM is very bad. So I need to do SVM by testing with the all parameter that SVM has and show it to you that SVM is not bad as that I mentioned.
Really? Okay. Good. Okay, thank you very much, Naswa. Thank you very much for a very good presentation. Thank you.
Okay, thank you.
All right. Okay. Bye. Assalamualaikum. Is
Salam.
there anyone left?
No, sir.
No, you're
Just-
the last one. Okay, thank you. See you again. Thank you. Bye, Naswa.
Assalamualaikum.
Okay, Assalamualaikum.